everyone. And we're live.
Hey, welcome everybody. Welcome to the 6th in our monthly presentations of virtual astronomy outreach events brought to you in collaboration the Riverside Astronomical Society and the University of California at Riverside, the Department of Physics and Astronomy. My name is John. I'm the director from the outreach program at the Riverside Astronomical Society, and I will be your co-host tonight, along with Sinan.
Good evening, everyone. My name's Sinan Du, and I am in charge of public outreach and education in the Department of Physics and Astronomy at UC Riverside. My professional background is astronomy, and I study galaxies that are really far away from the Milky Way. We're very happy to see the collaboration with the Riverside Astronomical Society to get really far away, and we're now even in 2021. So we're very excited to bring you back the monthly Stargazing program now with a slightly different format. So today we'll together have a virtual tour of the moon. Are you all ready?
Yeah, so we're looking at the moon tonight. And typically when, astronomers don't like the moon very much because it makes a bunch of light up in the sky, makes it hard to see galaxies and other faint things that are far away. But tonight we're focusing on the moon all night long. It's all the moon all the time because it's actually pretty close to us compared to other celestial objects. It's only about 240,000 miles away, which again is pretty close in terms of space. And it doesn't have any atmosphere or clouds that get in the way of us being able to see its surface details. So even a really inexpensive telescope you buy at Big 5 is going to show you amazing details on the moon. So we're going to be looking at 5 different things on the moon. And the actual list of our targets is in the chat box. So you can check and see exactly what we'll be looking at. And again, for all of our events, the bigger the screen that you can access for tonight's show, the better. If you're having to look at us on a phone, I guess that's okay, but the images we're going to be able to show you will be much more impressive if you could see them on your computer desktop screen or your television. So if you can go that route, I would suggest it.
And next, I will introduce our lovely volunteers tonight with us, who some of which will be moderating the live chats on the right-hand side of the website page. They are Garrett Lopez.
Hello everyone, my name is Garrett Lopez, and I'm a second-year graduate student at the University of California, Riverside, and I study the effects of dark matter on the universe. I'm glad to be here.
Thanks, Garrett. And Jessica Doppel.
Hi, I'm Jess Doppel. I'm a fourth-year PhD candidate at UCR, and I study globular clusters, dwarf galaxies, and galaxy clusters, and I am super excited to see what kind of questions you guys have about the moon.
Thanks, Jess. Next, we have Franco Iglesias.
Hello, my name is Franco Iglesias. I'm a first-year graduate student at CSULA Physics and Astronomy Department. I'm going for my master's. I'm excited to be here, guys.
Thanks, Franco. And we also have Cheryl Wilcox.
Hi, everybody. I am a middle school science teacher by day, a UC Riverside graduate, go class of 85. And I've been a member for over 30 years of the Riverside Astronomical Society and look forward to answering your questions tonight. Enjoy.
Thank you, Cheryl. And there are 2 more chat moderators who you cannot see right now on the camera. One is Yoongda Ju, who is a 3rd-year astronomy graduate student at UCR, studying the early universe and the medium between galaxies. So he's wisdom tooth removed yesterday, so that's why he cannot talk right now. And the other one, we have Rudy Garcia, who is a graduate student in education, but he got his bachelor's degree in geophysics. So he's also an amateur astronomy and will be able to answer all your questions related to the moon and other fields in astronomy. So the other telescope operators that you can see will introduce themselves when it's their turns. In the chat bar, we welcome all kinds of questions and comments and encourage you to engage in discussions. So most of the questions will be answered by the chat moderators, and the remaining will be answered by the panel. This is the 6th stargazing event we've had, and we're very excited to see the crowd growing. We can recognize some of the returning participants, and we're also excited to see all the newcomers. So we certainly love to collect your feedback on how we did tonight so that we could improve our program next time based on your needs and preference. If you have already been with us for a while, you could probably tell how our program has evolved and how your comments have been addressed. So finally, for those who will be staying with us until the end of the event tonight, we will have a chance to enter you to a raffle. Our prize is this beautiful NASA calendar provided by one of the NASA Solar System Ambassador, Jose. So Jose, would you like to show everyone the calendar?
Yes, okay. Good evening. My name is Jose Castro, and I am showing you the beautiful calendar for 2021, not 2020. Okay, I'm trying to get away from the gloss here, but it's beautiful calendar with lots of information, lots of pictures, beautiful pictures, and it talks about the, where are you? It talks about the different scientists on the history of NASA. So I'll be more than happy to provide these for the raffle tonight. So good luck to everyone participating all the way to the end.
Thank you very much, Jose. All right, so well, in the end, we'll share a Google form link for the raffle, and we'll contact you if you win. So without further ado, now I'll give it back to John. Oh,
Well,
sorry.
I'm going to give it right back to you.
Oh, okay.
Our
yes,
first trivia question.
That's true. John will not say anything because it's my turn. Okay, so the first thing we're going to do is I'm going to post a trivia question, which you can see right here. All right, so this is a question for all of you. When you see a full moon, what are the relative positions or alignment, as you call it, of the sun, the moon, and the earth? And what about a new moon? You can type your answers into the live chat. And if you think that's just way too easy to answer, we have a different question for you, slightly more difficult, okay? So if you think that is the alignment for a full moon or a new moon, then in that alignment, why do you not see a lunar eclipse every month? So think about it, and we will reveal the answer after Jose's target. All right.
Okay. All right. Who has? All right. Are you seeing my screen here?
Yes, we are.
All right. So good evening, everybody. Again, my name is Jose Castro, and I am the Assistant Director of Outreach for Riverside Astronomical Society. And my purpose here tonight is to show you the full disk of the moon. Obviously, we're only going to see half of it because of the phase of the moon right now. But we're going to be looking at different areas, the dark areas, the light areas. We're going to learn the names of those areas and the reason why they look the way they do and why they're called the way they are called. Now, the name, most of the moons in the solar system has a name, but our moon is like an abandoned stepchild. It does not have a name because when they actually name it back in ancient times, they didn't know there were many moons, about 190 moons in our solar system. So they just call it the moon, and they left it at that, just the moon. And it's curious because this is the 5th largest moon on our solar system. So it's about less than a quarter, a little bit less than a quarter the size of the Earth. Yet it has a lot of beautiful features that we're going to learn about them tonight. And Again, I think that John mentioned this. The distance of the moon is about 240,000 miles. I would like to stop sharing here now, and I'm going to change. I'm going to show you what the moon looks like as it rotates, and you can see in the background the different plane of the orbits of the planets and certain probes and rovers and different gadgets that NASA has going around. Right now, you're seeing a black moon because it's right now it's in the shadow of the Earth. So obviously, you're gonna see as it passes that stage right there, it's gonna start getting lighter and lighter. And it's going to start going through the phases, which you're going to be learning about those phases later on. What are they named and why are they named like that? Okay. So, what can I say? It is important to know that the Earth and the moon are locked up in the tidal attraction. And so, you know, the moon is locked to our orbit and the gravitational pull. Also, it affects, it doesn't control, but it affects the tidal waves, the level of the oceans, and it also has something to say in our Earth climate. All right. So somebody a few days ago asked me if it's true that the moon has something to do with human health. Yes, in my opinion, it does. A lot of people emotionally are attached to the moon. Some of them are attached to the earth and the ocean and the tides and the sea level. And there you have almost a full moon showing the most spectacular mare and a chain of mountains and craters. And I'm going to pass it on because that's my presentation. Thank you.
Thank you, Jose. Now it's my turn to share a little bit. So what I'm not dealing with telescopes here tonight. I'm just talking about everybody pretty much on the surface of this Earth. Everybody who lives on Earth has seen the moon go through these phases as it changes from night to night over a period of weeks, growing larger and larger or shrinking, disappearing altogether. And you might have heard the terms waxing moon or waning moon or a gibbous moon. And some of you, of course, I'm sure know exactly what that means, but I would guess there's plenty of us here tonight that have no idea what is a waxing moon. So here's a quick lesson. If you look here, we'll start out with a new moon. And the new moon is pretty much invisible because it's up in the sky right next to the sun and we really can't see it. But as eventually it starts to move away from the sun, we start to see a young moon, a very thin crescent, and we see a fatter crescent. And we're calling this, as you might see the terms here, a waxing crescent. Waxing because it's getting bigger, getting more illuminated. It becomes a waxed quarter moon, even though it looks like a half moon. We call it a quarter moon because it's 1/4 of its way through the lunar cycle, which takes 4 weeks. Eventually, the waxing moon becomes gibbous, which means it's fatter than just a regular quarter moon. It's more than half illuminated. And eventually it becomes a full moon where the entire disk is illuminated. And then right after that, it starts to shrink. And when it's shrinking, we call it a waning moon. So here we have a waning moon that's also gibbous, right? Because it's more than half illuminated. Here's a waning quarter. It's still shrinking, and now it's 1/2 illuminated, but it's a third quarter going through the monthly cycle. And then we have a crescent moon, a waning crescent, and crescent means it's less than half illuminated. Now, the way I think of it, the way I can remember this is when you look at a waxing quarter moon, it's not too hard to imagine that is a capital letter D for in the waxing quarter. So D, I would suggest, could stand for daring or being brave. The moon is daring and is growing bigger and puffing up its chest and getting more and more illuminated. Whereas a waning moon is kind of a timid moon. It's shrinking a little bit. So when you think about a waning quarter moon, it's not too hard to think of that as a capital letter C for cowardly. So a waning moon is cowardly and timid as it shrinks all the way to disappearing altogether. So the waxing moon is getting bigger, and looks, if you're not sure what time of the month it is when you look up, if the moon looks like a capital D, it's daring, it's waxing, it's getting bigger. If the moon looks like a capital C, it's shrinking and becoming more timid, cowardly. And then crescent moon, less than half illuminated. Gibbous moon, more than half illuminated. There you go. Now you know a lot more about the moon than maybe you used to. So with that, we're going to go and check out what is the answer to those trivia questions about the moon that we just heard. So, Garrett, what can you tell us?
Thanks, John. Yeah, I can answer that. So a great animation from YouTube that I found that kind of gives you a picture of how these phases are connected to where the moon is in its orbit. So in this animation on the left side, this is where the sun is. You see it illuminating the Earth and the moon. So you see when the moon is full, the moon is furthest away from the sun. And as it goes along its orbit, you see that as it moves along, now you have a half moon, and as it keeps going, it'll keep getting darker and darker until that's a new moon. And that's when it's in between the Earth and the sun. So what's happening is that the side of the moon that's illuminated is not the side we see. And you can kind of see how the orbit and the phases are connected. So that might make you wonder, okay, well, if the moon's going around the Earth and going in between the Earth and the sun, why isn't there a solar eclipse every month or a lunar eclipse every month? Well, what happens is, as it goes around, this orbit wobbles. In order for it to make a shadow on the Earth, it has to be aligned just right. So sometimes it goes above, just like this animation shows, so it doesn't make a shadow on the Earth, and sometimes it goes below. So it has to be just right. It has to be a perfect timing of when it's in front, exactly aligned with the Earth in order to make a shadow. That's why we don't see a eclipse every month.
Excellent. Thank you, Garrett. All right, so now let's get a close-up view of the moon. Randy's going to take us in close and show us something that's a little hard to explain. What the heck is that? Randy?
Okay, let me switch over here. Hit that, and I'm going to switch over to a different camera, if it'll let me. It won't let me switch. Hang on.
That looks good, Randy.
Okay, so you see something?
Oh, yes.
Yeah, I don't see anything.
Well, we're now seeing you sharing the Zoom
Okay.
web portal.
Yeah, the image that you see of the moon is where you normally would be seeing you.
Yeah.
And it won't give me a full screen. I can't put a cursor over it.
Well, would you like some time to figure out?
We can come back.
Yeah.
If you wish.
So should we move to the chat room?
Yeah. Do we have any interesting questions that have already been filling up the chat?
Well, I guess, yeah, they are being answered, and we haven't got anything that needs to be answered by the panel. So we're doing good. Yeah, and we also encourage everyone to keep asking questions, and if you have anything, just put it in the chat. Oh, okay. Well, actually, there is one good question. So Carrie McManus asked, well, sorry, I think that might be from a different person. So why does the moon stay in the same place?
I'm not sure if I understand what that means. What is it to be in the same place?
Well, I'm guessing maybe it's either regarding the distance or regarding the tidal locks.
I think that they're talking about the tidal lock between the Earth and the Moon, and
That makes
that
sense.
we just see the one side of the Moon. We don't get to see the other.
Yeah, that's a good answer, Jose. And I would also say, well, because the Moon and the Earth now is already tidally locked, right? Which means you are essentially always seeing the same side of the Moon. So it's not necessarily like in the same place, because the Moon is not traveling in a circular orbit, but it's a little bit elongated. But yeah, we always see the same side of the Moon.
And a little bit of interesting trivia there is many of the moons in our solar system have a tidal lock with their planet, and the same face of that moon faces that planet. It's not just our moon that has that.
By the way, the definition of tidal lock would be that the moon has a mass a little bit more on one side than the other, and that mass is always pointing towards the Earth, and as a result, the tides are locked together. It's always pointed at the Earth.
Yeah. Well, thanks everyone for the answer. And next question from Mel Evans. What causes a blood moon?
All right, Brian, go for it.
So blood moon is quite the spooky name. That's actually a description of what would appear to be a full moon, but it's during a lunar eclipse. So this is when the Earth is specifically very close between the moon and the sun, such that the Earth's shadow completely blocks off the moon, which causes an eclipse. But at the same time, the sunrises and sunsets from the edge of the Earth shine red light towards the moon, which gives it that slightly rust or ruddy red color. So that became the name blood moon.
Excellent. Any other questions?
Yes, there is one more question from GPS Communication and Transition, asking why do some moons rotate and some don't?
Actually, our moon is rotating. So when we're talking about it having a tidal lock, so this face of the moon is always facing the Earth, the same face, that doesn't mean that the moon is not rotating. It just so happens that the period of its rotation is exactly the same as the period of its orbit. So the moon rotates, every place on the moon has day and night. It takes like 29 days, the same amount of time it takes for the moon to orbit the Earth. So they're all rotating. All the moons are rotating. Some are just also locked because of their relationship and with the gravity of their host planet.
Thanks, John. And if I may add to that, some of the moons are locked and some are not. Well, eventually, if given enough time, and if the planet also has some sort of elasticity surface, then eventually all the moons will be locked with the planet. So if some are still rotating with respect to the planet, that means we simply just haven't really given it enough time to see the tidal lock. But for our moon and the Earth, there is enough time. So that's why we're seeing them locked already. Okay, well, I guess that's the questions for now.
Randy, are you ready to go? Or should we come
yes,
back?
I am. Yes, I am.
All right, take it away, Randy.
Okay, here goes. I'm going to switch over to a video. I'll put on share on the desktop and get rid of some junk here. Why is this coming up? I mean, I'll see if I can get a video going here.
Oh, we see it.
Okay. Here we have a feature called the straight wall. It's right here. It's actually not a wall. the original name is Rupus recta, which means a straight cliff. Actually, what it is, this is on the southeastern corner of Mare Nibium, which means it was a large lava flow that came through here. And whatever forces that happened underneath this surface here caused what they call a normal fault. This is an example of a very straight fault on the moon, just like we have faults here on the Earth, that's about 100 miles, let's see, or about 70 miles, not quite 100, 70 miles long. And from this surface down here to this surface up here is about 1,000 feet of elevation difference. This has collapsed over here. You see a big black line going across here because that's the shadow. The sun is at such a low angle that you're seeing a big shadow go across it. What it really is, it's not a cliff, it's not a wall, it's actually a slope. If it ever snows there, that would be a great place for beginners to try out their skiing, because it'd be around about a 7-degree slope overall. The structure is a couple miles wide, and like I said, 1,000 feet from bottom to top, and that'd be quite a lot of beginners, over 70 miles worth. To give you a little bit of reference, this little crater over here called Burt is about 12 miles across. This other crater over here is about 14 miles across. And I think it's called Thebit. This big one over here is in the neighborhood of 50 miles across. So you kind of get a little bit of relationship of what's going on here. Let me switch over to a still picture here real quick and minimize that. And we'll go to this. This is what it looks like a different time of day for the moon. Instead of sunrise, this is getting close to sunset. The shadows are on the other side. And again, you can see the straight wall here and another half-buried crater, which looks like a handle, and then a jumble of rocks over here. Put these all three together, and a long time ago, in 1700s, Christian Huygens named this the sword, which it kind of looks like. But in this case, since this slope that you see here is lit up, it's not a big black line like the other is. So this is at sunset on the moon. Let me go over to this one. If you were in orbit, which obviously we're not around the moon like that, you could get quite a bit closer picture. Geologists say that this straight wall area, this slope actually, is actually about 5 sections. And as it's all collapsed on this left side over here, it kind of split both directions at the same time. But if you decide to go on a nice little vacation, get away from it all, and you want to go to the moon for a few days, while you're in orbit, take a look down, and this is what you would see as you go around the moon. Now, about a month ago or so, I tried getting really close and kind of doubled the magnification. Let me see if this will work. There we go. And made it a bit larger, but it also unfortunately kind of made it a bit blurrier. And also you can see all this movement. That's the air on the Earth messing up the picture.
That still looks really cool, Randy.
Yeah, it's kind of nice. It would be better if it was a little stiller, but you get to see what it is and close up. And it's one reason why a lot of us observers kind of like looking at the moon, because if the night is very still, these features can be quite clear. Other than that, that's it for me. So I'll turn it over to Zenon.
Thank you, Randy. Okay, Sinan, do we have more questions for our trivia contest?
Yes, we have one more, and it is right here. So the next question that we're asking you is, do you think all the features on the moon formed at the same time? And again, if that is way too easy for you, here's another question. Well, if not, which features do you think are older and which ones are younger? So put your answers in the chat. And again, we will reveal the answers right after the next telescope target. And,
all right, let's go to Alex, who's going to show us an amazing mountainous region of the moon known as the Southern Highlands. Alex.
Hello, everybody. Thank you, Zane, and thank you, John. I'm Alex, and I'm here in Moreno Valley, and with my 9¼ inch Celestron telescope. I'm going to show you an area known as the Southern Highlands on the moon. I'm talking about this area on the moon here. You can see it in the live view over here. This is the actual view of what you're seeing. And let me get this to advance here. There we go. You can see that it's white. It's lighter than these other areas up there. It's rugged and cratered. It's not like these smooth, dark areas, the Maria. Now, we've had a lunar orbiter fly over the moon, bouncing radar signals off the surface. With the return of the radar signals, we can map how high the surface of the moon actually gets. Now, you can see that on this map. The dark blue areas and the purple are the lowest. And then the yellows are about moderate. And then the red, which is on the back side of the moon here, is about the highest areas. The area we're talking about, the Southern Highlands, fits in pretty much the yellow category mostly, which puts them about 10,000 feet higher than the blue, than this bluish area, the Maria. Now, you can either be looking at the slides as you go along, or if you enjoy it more, this is a live view of the moon. And I'm going to bump this up a little bit so you can see it a little bit better. And these are craters right there as they are right now. And you can see that it's heavily cratered. Now, just what makes these highlands different from the Maria? Hard to do. I don't have my fingers all in great shape here. Originally, they were all cratered. Everything here looked like it does down here. The Mare formed, and then they wiped out the craters, leaving heavily cratered areas alone. Currently, you have, to understand all this, we need to realize that shortly after the moon formed about 4.5 billion years ago, it was hit with many leftover meteors, and it got cratered all over. The whole moon had craters. The whole moon looked like these Southern Highlands looked, okay? Then the Maria formed. These dark areas are, you see on north, in the north here, are the eyes and the mouth of the man in the moon. And they formed from darker basalt lava flowing up from the center of the moon and covering, and just basically covering the surface and melting away the surface that had been cratered before. The basalt just flowed up and the molten rock melted away everything that was on the surface, replacing the white, rough, cratered area, like down here, with smooth pools of dark basalt lava. They cooled into these smooth surfaces that look almost like lakes or seas, and that's how they got their names, Maria. The surface not touched by the Maria, this surface down here, is actually older and more cratered, and it's higher and brighter. If we look over here, you can see it's called albedo. It's what makes part of it whiter and other parts of it gray. The gray part of the Mare reflects about 7 to 10%. These areas here are reflecting about 7 to 10% of the sunlight, making it about as bright as a newly paved parking lot with fresh black asphalt. On the other hand, the albedos of the highland down here is only about 18%. Only about 18% of the light is reflected from the sun. And so, or more, about 18% is reflected, and that makes it much brighter than this 7% down here. In a telescope, the highlands have lots more craters since none were erased by the lava flowing over the surface. Now, you may ask, why didn't the Maria up here get cratered eventually? Well, in fact, they do get craters. You can see little craters all over the Maria up here. But most of the cratering took place in the early formation of the moon and the solar system. Back when the solar system was young, there was a lot of stuff flying around the solar system, a lot more junk, meteors, asteroids, meteoroids, all sorts of junk just flying around. When enough of that stuff gets together, it makes a planet or a moon. And then once those moons and planets are formed, anything that's left over and still floating around and bumps into one of these moons or planets makes a crater. When a big piece of junk hits the planet, the crater's big, and we've got different sized craters all across the moon. But there's always lots of craters hitting it. However, most of that stuff eventually settled out. See where it says the cratering of the highlands? Actually, everything was being cratered. Everything once upon a time looked like this area down here. No matter where it was on the moon, it all looked like the southern highlands, lots of craters on it. Then the Maria formed. But you notice the Maria formed when the number of craters, the number of things that were hitting the moon had already cut down. And they're just, in the last 4 billion years, not too much of that has gone on. That's why up in the Maria, there's not as many craters, and there's a lot more left over from the southern highlands, which is where we're visiting. And I want to thank you for visiting the Southern Highlands with us today. I hope you picked up a little bit. And now I think we're going to turn it back over to Zenon so she can help us with that trivia question.
Oh, well, thanks, Alex. It's actually Rudy's turn. So, Rudy, you ready?
Yes, I am. All right, just a second here. Let me go ahead and share.
I can see that you've already changed your name to the Moon Man.
So. I wanted to make sure there was a distinction as to who was where.
Yeah, please share the screen whenever you're ready.
Of course. You don't want to cooperate, do you? Sorry, I'm using two computers at the moment, but I have a backup, and I'll go ahead and do that. It just might look a little weird on your screens. Okay, let's do that and share.
And by the way, I can see that there are a lot of great questions in the chat. So thanks everyone for participating. Our chat moderators are doing their best to try to get back to each of you.
Okay, can everybody see that?
Yes.
All right, so let's go very quickly over the areas of the moon, which are the lunar highlands, what I have deemed the older crust, and the lunar morae, which are the younger lava flows, as Alex had pointed out. So those areas, as he highlighted, are here. Here are the highlands. They are the lighter with a higher albedo, and the morae, which are the darker ones. And to quickly go over the moon's history here, the moon is formed roughly at around the same time as the Earth. The moon crust begins to cool, and funny enough, in this picture, it shows the core, as someone had pointed out in the chat. The core is there, but in earlier times of the moon, it was much closer to the surface. It cooled outside in. And during the late heavy bombardment, if you can see these big chunks of rock, they slammed into the lunar crust enough to crack into the mantle, which let all that lava seep out, and then created the lunar morae. Those large impacts broke through, the magma began to cool, and as time progressed, the mantle began to cool from the outside in, leaving what the moon that we see today. And I think that would be it for my little presentation here. I guess now it's going back to the trivia and answering those questions.
Great. Well, thank you, Rudy. So next, we are turning the stage to Manny.
Take it away, Manny.
All right, let me get my screen sharing here. I wanted to show this first here. Let me go start this. So my name is Manny Lines. Often you will see me from my observatory up in Northern California, Central California, but today I am coming to you from lovely, but a bit cool, Chino Hills. So today we're going to talk about Montes and Maria. So you've heard both Alex and Rudy talk about this some. So before I show you that that image of the moon, I'm going to talk to you. I'm going to give you a little commercial announcement. So these images of the moon that you're going to see are being brought to you by this little telescope right here. This is a 5-inch diameter telescope. It's a Meade ETX 125 for those that are interested in the specifics. And there's a special cooled color camera right here that is behind that telescope capturing the images that are then going via a USB cable down to a laptop. And then right here I have a tracking mount, and this is tracking the moon so that we can keep it in the field of view for the duration that we're looking at it. So here is a live view of the moon, and you can see here, this is our 9-day-old moon. Here we're tipped a little bit on our side here, but this is these are the southern highlands that Alex was just talking about. And here are a couple of the Maria and some of the mountains that we're gonna talk about. So let me flip back to my charts here, and let's go to the let's talk about lunar mountains. So here we have, in this view, we have these two sets of they look like little bumps here, but they're actually quite tall mountains. And let me go ahead and zoom in on this photo here on this a little bit. And so we're going to get a little bit of closer view. So you can see right here, this is these are the mountains we're talking about. And these are the Apenninus and Alpes. So you probably figured out by now Montes means mountains. So the Apenninus, named after the Apennine Mountains in Italy, are home to actually the 3 tallest mountains on the moon. Mount or Mons Huygens, Mons Hadley, and Mons Bradley. Now, the interesting thing, if you remember Alex's presentation, he was mentioning that the highest areas of the moon are actually on the far side. So actually, those areas, 35,000 feet in elevation on the far side of the moon, the side that we never see from Earth. But these mountains, nevertheless, are the highest. Why do you say that? The far side of the moon, although the surface is higher in elevation, it's relatively smooth. So if you were standing there, you would look out and you would see just little hills or craters in every direction. You wouldn't see something that we know here of on Earth as a mountain. These are mountains in the real sense. If you look at these, the distance above the surrounding plains is actually higher than greater change in elevation than from the plains of Nepal to the top of Mount Everest. So these really are quite tall mountains, although their peaks are lower than the highlands on the far side. So kind of an interesting paradox there. So the Alpes here, not as high as the Apennines, 6,000 to 8,000 feet high. And both of these mountain ranges were formed by a massive impact. And we're going to talk about that a little bit more. So you've heard the discussion about Maria, which of course means seas. And we're going to talk a little bit more about Mare Imbrium here, which is this very large area. And you can see there are some craters inside, but quite a large area. So this is actually No kidding. This is a crater. It doesn't look like a crater. It kind of looks like a flat plain with some mountains on the edge. But no kidding, that is a crater. And you heard Rudy just talking about the late heavy bombardment. And boy, the moon really did get bombarded about 3.9 billion years ago. They're calling it not an asteroid, they're calling it a protoplanet. That's like bigger than an asteroid, hit the moon. And the estimate is that it was probably about 155 miles wide. So if you think about that, that was quite a massive impact. And when that hit, it literally liquefied this entire area. So this is Mare Imbrium as we're looking at it in real time. So this entire area, imagine this massive impact of a protoplanet and it just liquefying all of the rock in this area, and then throwing up these scarps, these mountains in all directions. Then finally, over the millennia, the Mare cooling into this flat plain, and then of course later on more impacts of smaller objects creating these younger craters. Now, so let's talk about an interesting thing about this particular area of the moon. So I was fortunate enough to draw the mountains and the Mare Imbrium in particular, and that happens to be where the Apollo 15 spacecraft landed on July 30th of 1971. Three Americans, Al Worden, who flew the command module around and around the moon about 75 orbits, while his compatriots David Scott and James Irwin spent 3 days on the surface of the moon, collecting rocks, doing science experiments, and jetting around in this lunar rover, which they call the LRV, the Lunar Roving Vehicle, which was the first car on the surface of the moon, which I think is kind of cool. And it's still there, by the way. So here is a nice close-up of the area where they landed. This is Hadley Rill, really an interesting place near, if you remember, I talked about Mount Hadley, the second tallest mountain on the moon, right here. So let me flip back to the live view now, and let's zoom in a little more. Let's go to, well, let's go right up to 100% here. So right here in this area, this is Mount Hadley right here. And then right here is just a little bit below our ability to detect it, but this is Hadley Rill right in here. And the area where the Apollo 15 spacecraft landed is just about right where the point of my arrow cursor is, right here. And of course, that lander is still there. I'm going to take you to the next view, but we'll talk a little bit about Hadley Rill, which is this. This is actually a canyon. It almost looks like a water channel, but of course there never was any water on the moon. So we believe that this is formed by lava flows. And if any of you have ever been to Lava Beds National Monument way in the north part of California, you'll find lava tubes there, which you can go exploring, which is very cool. But anyway, they're thinking this might have been a lava tube that the ceiling had collapsed on. So not sure, but pretty interesting place, and the astronauts got to explore that. So here is a close-up view of the lunar surface. And this is taken from orbit from an orbiter called the LRO, the Lunar Reconnaissance Orbiter. And then right here, this bright spot is the lunar module. Now, you'll see something interesting. All these little tracks here, these are actually the tracks made by the Lunar Roving Vehicle. And I think there's some going in this direction too. So you can see back and forth here, all of these tracks created by the LRV, the car on the moon. And these tracks are still there, and they will be there for thousands of years because there's no wind, there is no rain, and there is no water to wash them away. So they will be here for a very, very long time. And just a little cool factoid. There's a little device here called the Lunar Ranging Retroreflector, which is kind of a mouthful, but it's basically an array of mirrors. And what we are doing up to today is bouncing laser beams off this reflector and using it to measure the distance from the Earth to the moon with very, very high precision. And we have learned as a result that the moon is moving actually away from the Earth due to tidal effects. The moon is actually drifting away from the Earth about 1.5 inches per year. So over thousands, millions of years from now, the moon will eventually drift off and go its own way, independent of the Earth. But that will be many millennia in the future. So that is all I have for you today. I will turn it back over to John.
All right, thank you, Manny. So I understand that our chat room is getting inundated with questions.
Yes,
So,
we've got several very good questions. There's one from Remble, 6-year-old, who wants to know how craters get their names. And there's also Jennifer Gomez, 11-year-old, wants to know why the craters are circles and why they're all so perfect. So I guess we're gonna save those questions to Brian, our last speaker, and he's actually gonna answer that during his presentation.
Okay.
Yeah, and other questions. We have Mara O asking, did all the moons in our solar system form in a similar way?
Hi, can I answer that one?
Go ahead, Alex.
Okay. No, they don't. They form in lots of different ways. Our moon, we don't know exactly how it formed. Nobody was around back then, but we expect that a fairly large planet, planetoid, smaller than the Earth, but pretty big, hit the Earth and knocked the top part of the Earth and itself back up into orbit. And in the course of several months, several years, and very quickly actually, a lot of the pieces came back together again and formed a moon and was orbiting the Earth. And I think that's the rest of that story. I'm not sure we can go into all of the story. But other moons are formed in many different ways. Now remember, a moon is something that orbits a planet. That's all it is. It's a moon orbits a planet. For instance, we've launched some rockets that have gone off into the distance and near the sun, and then they eventually came back and they kind of started circling around the Earth. For a while, they were moons. Sputnik was a moon. Remember that. Well, this same thing can happen. I think you remember back when I was talking to you earlier, I said that there was lots of junk flying around in the early solar system. Well, some of that junk would get together and some of that junk would hit planets. Some of that junk would get close to hitting the planet, but kind of miss the planet and just kind of circle around and then circle around. And as it kept circling around the planet, it became a moon. So Deimos and Phobos were probably captured asteroids. They weren't made the same way that the Earth's moon was made. They were probably just pieces of space junk, pieces of rock and stuff that were just floating around out there, and they got captured. Other moons, well, other moons could be made from, maybe there was a planet passing close to Jupiter and got torn up, but still had some speed, and so it continued to circle around in an orbit. Remember, anything that orbits a planet is technically a moon. Most of them around the Earth now are man-made, but occasionally, besides the moon we all know, the big white thing we've been talking about today, occasionally we have other moons, believe it or not, other natural moons that orbit around the Earth. They only last for maybe 20, 30, 40 orbits or something before they get bored or something and fly off with their orbital mechanics. They go off someplace else. But there's lots of ways to make a moon. Okay?
Thank you, Alex. Next question is from Genesis, asking, why doesn't the moon have the same properties as the Earth, as if it was one of its moons? Like, why don't all the planets have a little child like them? I think that's a very interesting question, and I'll try to tackle that. So as you'll hear from the moon formation story John and I will be presenting very soon, well, the entire solar system actually formed from a very flat disk that's full of gas. So when planets form and the moons are the moons of the planets, they were also formed, they could have been also formed in the same gaseous disk. The planets, just because they started with heavier or larger seeds, that they started to attract more gas or more mass, and they grow larger. But for the little moons, just because they were more spread out on the outer skirt of that disk, the properties of the gas, or like we say the chemical compositions, or like what metals, what elements are in those areas where the moon formed, that could as well be very different from the central, just because you have gravity to pull all the heavy things in, right? And you have like more tenuous and lighter elements at the outer side. So that might be one of the reasons why, normally the planets do not have exactly the same properties as their moons. And of course, if a moon is captured, so that's completely different from how the planet was formed, right? So that's why another reason why they could be decoupled. And one other question from Maria Stengeland asks, how do you know the age of the features on the moon? Yes, that was referring to the mares and the craters. Anyone wants to take that? Brian?
So I can take a stab at that answer. And Moira had asked another question about craters on the Earth versus craters on the moon. But the first question, how do we know the age? Well, that's actually a question we are still asking ourselves about the age of the features on the moon. It first started where the astronomers would literally count the craters. And we have an idea how far back in time we had large bombardments where a tremendous amount of rocks and comets and such were hitting the rocky planets and really all the planets. So by counting, they estimate how long ago those were created. We have an estimate for the moon. But thanks to the Apollo astronauts, they've brought back rocks. And using radioactive testing, we've started to test the age of those rocks, and we're getting a better idea. And as far as the craters, we're estimating that many of the craters on the moon are up to or farther back than 2 billion years old. So there's some really old features on the moon. Would you like me to answer the question about craters on the Earth versus the moon?
Well, I guess we can save that later.
Sure.
Yeah. All right. So I guess now it's our story time, John.
Stories. Stories,
finally.
All right. So get your cup of hot chocolate, sit back, and listen to the story of the moon. A long time ago, like 4.5 billion years ago, the entire solar system was formed out of a giant cloud of gas and dust. One day, a nearby star exploded and sent a shock wave through the cloud. The shock wave made the cloud start to collapse onto itself due to gravity. As it collapsed and shrunk, the cloud grew denser and hotter in its center. Eventually, it became so dense and so hot that it ignited and started to burn, and that is how our sun was born. The sun was surrounded by its own giant cloud of gas and dust called the solar nebula.
As the nebula continues to shrink, it flattened out into a disk that started to rotate around the sun. For the next 10 million years, the heaviest molecules began to form tiny solids or liquid droplets, or what we call the seeds. The seeds then collided with each other and stuck together. Lots of clumps started to form and grow larger, eventually becoming so massive that they formed planets. After the planets formed, there were still lots of leftover small clumps whistling around and banging into things. Many of those clumps eventually plunged into the sun, never to be seen again. However, many survived and became comets and asteroids.
Now, at this time, the Earth was about 80% of its current mass. It was also a very hot and nasty place. There was no water, no atmosphere. Its rocks were still molten. The Earth had a smaller planet close by that was about the size of Mars. And now while the Earth was still growing its mass via collisions with smaller objects, such as asteroids, this small planet slammed into the Earth and was destroyed. It blasted a large part of the Earth and itself into space. Much of its mass fell back onto the Earth and helped the Earth grow larger. Some of the splash materials, however, went into orbit around the Earth and formed a magnificent ring system, much like the one around Saturn today. Over the next 1,000 years or so, these little pieces in the rings collided with each other and stuck together and formed larger clumps that eventually began orbiting around the Earth as our moon.
Well, both the Earth and the moon remained hot and nasty places for a while, but eventually they began to cool. As they cooled, the Earth and the moon formed a crust. Beneath the crust, they still remained molten. The solar system still had a lot of debris flying around, including comets and asteroids. The Earth and the moon endured many collisions with these things, which left both worlds pockmarked with impact craters. Some particularly large asteroids were able to punch right through the moon's thin crust and outpoured molten lava from the moon's interior. This lava spread out and formed large lakes. The lava cooled and formed the dark, smooth areas that we now call mare, or seas.
Now on Earth, most of these craters disappeared long ago due to the effects of erosion brought about by rain and wind and plate tectonics. The moon, however, has no wind, no rain, and no plate tectonics. So its craters remain visible to this very day. Even the footsteps that the Apollo astronauts left on the moon will remain undisturbed for millions of years. Thankfully, the solar system is a much quieter place now, with very few large collisions between planets, moons, and asteroids. But anyone who takes the time to look up and really ponder the moon will be reminded that our solar system was once a violent place, and the moon still has the scars to prove it.
Now, to be fair and more accurate, we don't really know exactly how the moon came to be. What was just described is the most prevailing and convincing theory astronomers have come up with based on the composition of lunar rocks. There are, of course, several other competing but less popular theories, such as the moon was captured by, or spun off from, or formed together with the Earth as a sister planet. As our scientific knowledge grows over the next several years, we'll find more evidence and grow more certain. So stay tuned. And that's the end of our moon formation story. Now I'm going to turn the stage to Brian to show the craters.
All right, thank you, Sinan. Let's talk about lunar impact craters. Here we have a view of the moon. And the name crater has come up many times, term crater, I should say, many times during our presentation today. You can't help but notice them whenever you look at the moon. So let's talk about the craters, and I'm going to bring up 5 specific craters tonight. So these were caused by impacts of objects like asteroids and comets. And so we actually call the objects that hit the moon, or really any other surface, we call those impactors. Some of the impact craters on the moon are estimated, as I mentioned earlier, over 2 billion years old. Now, Rambo had wondered earlier where craters receive their names. Interestingly, most of them were named by someone named Giovanni Riccioli back in 1651. And as of last December, just a month ago, the International Astronomical Union recognizes 9,137 craters. We don't have time to cover that many tonight, so we'll stick with 5. Let's talk about the first one. The first crater we're going to talk about is named Hercules. It is right here. You can notice that there's a pair of craters we're going to talk about, but this one on our view here to the left, you can even see a little crater inside it. This crater is named after the Roman mythological hero Hercules. It's 69 kilometers across, or about 43 miles. If you were to drive to UCR to Knott's Berry Farm, you'd cross that distance of this crater. It's pretty deep, just about 2 miles deep. What happens is astronomers will name the main crater or use the name that came back from Giovanni, and then they'll give craters inside that are smaller letters. So this crater we can see easily is Hercules G, and it's just south of the center. Now let's talk about Hercules' neighbor. That's Atlas, that we can see just to our right when we're looking at this view. This crater is named after the Titan from Greek mythology, much larger. We can tell even from this picture that it's larger. We're talking about 54 miles across, or 87 kilometers. That would be a drive to UCR to, let's say, Palm Springs. It's a little more shallow, however, at 1.2 miles deep. Something to keep in mind, as my friends have been pointing out earlier, this pesky lava likes to run into these craters. So even though the crater could have started much deeper from the impact, lava will flow in and fill the floor, sometimes even filling up the entire crater. Before we talk about our three others, let's talk about what really is forming these a little bit more. What happens with the craters? We have an impactor, some asteroid or comets flying along at a ridiculously high speed. As soon as it hits the surface of the moon or whatever planet or other moon it's hitting, a shock wave actually fractures the rock that it hit. Now, Jennifer had wondered why the craters are often so round. Well, this has to do with the ridiculous amount of energy that the impactor imparts to the surface. It literally just pushes debris in all directions, making that mostly circular crater. You have to come in at a very, very low angle in order to have an elongated crater. And the energy would also have something to do with that. So we see circular craters because there's so much energy. In fact, it's so much energy that the original impactor is usually pulverized into very small pieces. It might even melt or vaporize. In fact, it sometimes melts some of the surface of what it's hit. Many times an impactor can be so large that when it displaces all of that material, some of it hits the sides, splashes back up, and makes a little raised center in the middle. So from time to time, you'll see mountains actually in the middle of the crater, and that's from that returning material. All right, on to the next crater. We're going to come down here more to what would appear to be the south. You'll notice in this area where I'm circling with my arrow, we have three little craters that are all neighbors. 1, 2, 3. Let's start right up here at the one that's closest to our top right from our view. This is Theophilus, named after the 4th century Coptic Pope, Theophilus of Alexandria, 62 miles wide, or 100 kilometers, about 2 miles deep. This one has a central mountain, like what I just talked about. It climbs almost a mile up above the floor of that crater. That'd be 2 kilometers, by the way, for our users of the metric system. Right here, actually connecting, and these two craters even overlap, we have Cyrillus. This is named after another 4th century Coptic Pope, Saint Cyril of Alexandria. This guy is 61 miles wide, or 98 kilometers, 2 miles deep. This one's actually thought to be older than Theophilus. And one of the ways we can tell the relative age between craters is how defined their edges are. The more worn the ridges of the crater, the older it is. All right, last but not least, we have Katharina. This crater right down here, the lowest of our trio that we're talking about, it's named after St. Catherine of Alexandria. 100 kilometers, or 62 miles wide, just about 2 miles. I'm sorry, I actually put wide for both of these. So the larger number is wide. The second number is actually its depth, 2 miles. This is the oldest of the trio. So want to point out that one of the wonderful things about observing the moon is you get different features to enjoy depending on what phase of the moon you're at. So these are 5 that are enjoyable here at our first quarter. So I definitely encourage you all to keep on looking up at the moon at different times and start to learn these craters and see which ones you can identify. So I'll pass it back to you, Sinan.
Thank you very much for your presentation, Brian. Okay, so now I guess before we do a final chat room check-in, maybe it's time for us to do the raffle, at least to put everyone into the raffle, right? You guys are all ready for getting your calendar? All right. So let me put the link right here, and you can try to see if you can open that. And while you're doing it, we will answer some of the previous questions, which are really good. So the first one is from Alice, 6-year-old, who wants to know, why is the moon moving away? Manny, do you want to take that?
Do we have somebody to take that, Manny?
Yeah, I could take it. Sorry, I was muted. So that is actually an excellent question, and it's a little bit complicated. So I'm going to try to do my best to make it to make it a little bit easier to understand. So we've talked a lot about how the moon and the Earth are gravitationally locked together, and the moon affects the Earth by pulling on it and actually causes those tides. So the tides are caused by the water from the moon being attracted by the moon's gravity. So that attraction causes the Earth to swell up a little bit as the moon goes around it. And that swelling actually has the effect of slowing the Earth down just a tiny, tiny, tiny bit. So think about an ice skater who throws her arms out to slow down. That's kind of what's happening, is that water is being pulled off the Earth. So as that happens, that tiny, tiny slowing down of the Earth, because of conservation of momentum, if the Earth slows down a little bit, the moon's got to speed up a little bit to compensate for it. And so that change, that little tiny, tiny bit of slowdown of the Earth, tiny, tiny bit of speed up of the moon, causes the moon to just slowly move away. Because of what we call orbital dynamics. When an object that is orbiting another object speeds up, its altitude, its distance away from the object it's orbiting, increases. And so that's what's happening. That tidal effect of the Earth's water being pulled toward the moon by the moon's gravity causes the Earth to slow down a little bit, the moon to speed up a little bit, and therefore the moon to drift away very, very slowly.
Well, thank you, Manny. And next question is from FRXSTY, asking, why are the Southern Highlands only in the south? Why is it not like anywhere else on the moon?
Who's answering that, Sinan?
Well, no one signed up for it.
Okay.
Do you want to?
Let me just tell you that the Southern Highlands are named the Southern Highlands because they're the highlands in the south. Duh. That's simple enough. But in fact, there are highlands all over the place. If you remember from my presentation, I showed you a map of the area, and there are lots of highlands. Everything that isn't a Maria generally is an old highland. So the Southern Highlands are there, named the Southern Highlands because they're in the south. There are also Northern Highlands and other places, but the Southern Highlands they have certain craters there, and people who like to study the moon are off on naming it the Southern Highlands region. Okay.
Thank you, Alex. And well, maybe this question is also for you. This is from Moira Stengeland. Why don't we see as many craters on Earth?
And I'd like,
yeah, sorry, haven't finished the question. If the moon was being bombarded and has so many huge craters, why don't we see the same huge craters on Earth?
Okay, am I going to take that?
Yeah.
Okay, I'm sharing my screen, and I don't think anybody's going to have a problem realizing that, yeah, we got craters on the Earth. Okay, we got lots of craters on the Earth, and it pretty obviously those look just like moon craters, although curiously people did not recognize them as moon craters until relatively recently. This page here is just the image page for Meteor Crater, Arizona, and here's just a generic lots of different craters that you can find all over the place. All right. But I want you to notice that they aren't all out in the middle of the desert. You asked, how come we don't have any? Well, we do have more than you might think. Here's a crater called the Sudbury crater. But you'll notice that it's not a crater, it's a lake. You know, it's not a crater. Everybody thought that was a lake for a long time until somebody realized, wait a minute, with that shape, and then they studied rock formations and things like that, they realized that it's also a crater, an impact crater. And there are impact craters all across the world that we don't recognize because they've got trees and forests and things like that all around them and lakes. Okay. And the other thing you got to understand, I think we all know that, you know, the San Andreas Fault is moving the continents around, and and part of the continents are going underneath other parts of the continents, and land is turning over all over the place. Well, here on Earth, because we've got all that motion going on, the surface of the Earth is constantly recycled. In addition, just rainwater and everything washes away the rills, the valleys. Do you remember how Randy was telling us about that, you know, 1,000-mile long or whatever, 100-mile long rill that would have been filled up with water here on Earth. There would be trees on it. We wouldn't notice that it was any particular thing. Now, that wasn't a meteor crater, but you get the idea. We're covered with green vegetation, and we just don't see a lot of that stuff. And besides, a lot of it is recycled through plate tectonics. That's about it.
Thank you, Alex. And I just wanted to quickly add to the plate tectonics. Remember when Rudy was presenting, the mares are actually repaved surface by solidified lava, right? Or what we call magma. And because the Earth is still very geologically active, it has tectonics, it has volcanic eruptions. So sometimes, its surface also gets repaved. That's why the craters are not very obvious there. And note that the Earth is active because of its large mass. So it could retain a lot more heat inside. But the moon is relatively smaller, so it cools much quicker. And now it's, all the interior of the moon is almost already solidified. So there's no more lava or magma that's able to come out to repave the surface. And it all comes down to its relative sizes or mass. So I guess that's the questions that we're gonna take now. John, would you like to wrap up?
Sure. Oh, and one really cool little bit of trivia that I just learned this morning. As you may or may not know, we now have a new president in the United States, and the new president moved into the White House. In the Oval Office, you know, the seat of power, they decorate it the way they want, each president. So Joe Biden has a collection of moon rocks in the Oval Office, which I thought was pretty cool.
Wow.
Very well timed for our presentation. I mean, I actually called President Biden and told him, and so he arranged to do that.
Of course you did.
Anyway, so as we wrap things up, I just want to, reiterate that I am with the Riverside Astronomical Society. And our website's right here, and we are one of many amateur astronomy clubs scattered around the country, scattered around the world. So if you are still with us tonight, my guess is you like astronomy, and you might want to think about joining a club, because that's a good way to learn about stuff. And if you're anywhere in the Southern California area, you might want to join the Riverside Astronomical Society. Once the pandemic eases and we can start doing things again, we do a lot of fun stuff, so you might want to join us.
Great, thank you, John. And now I would like to share where you can follow UCR Astronomy if you're interested. Sorry, this is not the one that I actually wanted to show. Right here, I'm not sure whether you are seeing the UCR Astronomy page.
Yes, we are.
Okay, great. Yeah,
on Facebook.
Yes, on Facebook. So this is our official page, and we will be posting all the upcoming events on here. And as you can see, and some of you might have already known, Our next event is going to be on Thursday, February the 11th, about Orion and the winter sky. So I've already created a Facebook event, and similar like this time, if you're interested, quickly register, and we will be doing the communication through Eventbrite. And I know John also has some resources that would like to share with you, and I am posting those in the comment section. Not sure if you guys can see those already. So there should be 2 comments on this page.
Yeah, so just to let you know that if you are interested in astronomy, there's some excellent software you can get for your phone, for your computer. There's some great books you can read, books for kids all about astronomy. There's magazines. There's all kinds of good resources if you're like this kind of stuff, where you can educate yourself, learn more cool things. And there's a link to some of those resources, the ones that I find particularly good, that Sinan is pasting in the chat.
Yeah. So those are in the comment sections. So the chat box is on the right, and the comment sections is below the video that you're seeing. So I'll double check to make sure that it's actually posted. I might also pin it so you can see. All right, so I guess that would be today's event. Well, thank you everyone for joining us tonight. I hope you had a really good time here and enjoyed your tour of the moon. So as mentioned earlier, we would really appreciate your feedback on our event. And you would also have a chance to sign up for our mailing list in the survey that we sent you on Saturday. So it's all going to be an anonymous feedback survey form, and we'll only be seeing statistical results and your comments.
And in terms of entering to win the raffle, that really cool calendar from NASA, how do we do that?
Oh, good question, John. So we will be closing the raffle form around 8:30, and we will do a random draw, providing 4 NASA calendars to 4 winners this time. So if you win, we will contact you at the email that you provided us, and we will mail those to you.
Sweet. I hope I win.
Did you also enter? All right, so I guess that would be it for today. Well, thanks again for joining us and staying with us. And we'll see you February the 11th.
Bye-bye, everybody.
Bye.
Everyone.